All right, in the previous video, we took a look at how to write a formula using the subscripts, using the charges on ions that become subscripts behind the elements that are involved. We'll concentrate more on naming and as well as writing some formulas, but mostly naming on this one. And if we take a look at the chart here, I would like for you to think of a moment about what is the same about all the metal ions. And then what is the same about all the nonmetal ions? And then look at the charges on the ions and think about the subscripts in the formula. And then what do you notice? Okay. All right, so take a moment, pause the video, and jot down some notes about what you might think, and then come back and we'll discuss it. All right, now if what is the same about all metal ions? Well, they're all positively charged. They might have a different magnitude of charge depending on where you find them on the periodic table. Remember, group number tells you the charge on the ion, on the metal ion. Nonmetals, well, they're all negatively charged. All right, in this particular case, they have all of the 2 halogens, so they're -1. Oxide is -2. And again, it's the numbers of electrons that are added to the outer main level that create the charge on your nonmetal ion. Okay? Now again, let's look at the ion charges. Remember we talked about swap and drop to create your formula. All right, we're going to add a word here, swap, drop, and reduce. All right, because one of the properties of an ionic compound is that it must be in its lowest reduced ratio. So on occasion, you might need to reduce your subscripts if you're doing this swap and drop method. All right, but the other thing I want you to notice is your nonmetal ions. Look at the ending of all your nonmetal ions. They're all the same. The elements themselves for the metals, we use the element name. So that's an important pattern also. You always want to look for patterns in what you're doing to help you understand the why behind what you are doing. All right, the nonmetals, you're looking at that first prefix and then dropping the rest of the name. So iodine becomes iodide, bromine, bromide, oxygen, oxide. All right, so we're going to be naming these ionic compounds next. And I'll do this first one, and then you can stop the video and try the others, and then come back and check your answers. All right, so K, all right, that's a group 1A metal. It's potassium. And then we have O for oxygen. All right, but we got to remember to change the ending to "ide." All right, so potassium oxide. And I'm going to correct this because unless we're at the beginning of a sentence, we shouldn't uppercase the name. All right, so potassium oxide. All right, so pause the video and then come back and check your answer. All right, so the answers are on your screen now. CaO becomes calcium oxide. Al2O3 becomes aluminum oxide. MgCl2 becomes magnesium chloride. And there should be a space here. They look very bunched together there, so I apologize for them being so close. All right, so the next thing we need to consider, so far we've looked at the elements that are in group 1 and 2A, aluminum, and then these nonmetals over here. We looked at compounds from these 2 areas of the periodic table. Now I'd like for you to consider these elements that are in the middle of the table and these over here. All right, because they have variable charge. Well, most of them have variable charges. Some of them do not. All right, and those that do not should be noted. Okay, so if you've downloaded your PDF that has the reference tables on it, you can make some marks to show your patterns. All right, so when we write formulas that have these elements that have variable charges on their ions, we have to handle them in a special way. And we handle them by using Roman numerals to show the charge that we want to apply to the compound. All right, so this first question asks us, write the formula that forms between manganese 2 and fluorine. All right, well, we can come up here and take a look at manganese. All right, it's in group 7B or 7. It forms a +2 or a +3 ion. Okay, so that's why the Roman numeral is given to show you the charge that needs to be used in the formula. So it's giving you a clue. All right, so you should make use out of that. And so we want to use manganese, excuse me. That's a common error too, is to mix it up with magnesium over here. All right, so please don't do that. All right, so manganese is 2 plus, fluorine is -1, and then our formula is manganese 2 fluoride. All right, that's how we say the name. We say the name as manganese 2 fluoride, but the formula is MnF2 because it takes 2 fluoride ions to balance that +2 charge. Okay, now try the rest of these. All right, and I'm going to pause the video, and you can pause it too, and come back and check your answers. All right, let's check these first numbers 2 and 3 first. And again, we're trying to name the compound FeCl2. All right, we need to know the charge on the iron, so we can work backwards to find that charge. If we let X be the charge on the iron ion, and we know it takes 2 chloride ions to balance it, we know the overall compound must be neutral. All right, and then we can do a little solve for X. All right, so 2 times -1 is -2. X then becomes +2. So we know to use the iron 2, Roman numeral 2, version of this transition metal. And chloride is the nonmetal. All right, SnO2. All right, we need tin, and we need a Roman numeral for tin. And again, oxide will be the nonmetal. So again, we can do this, work backwards. X is for the charge on tin. We have 2 oxygens, each at a -2. Set it equal to 0. All right, and X becomes a +4. So our formula name is tin 4 oxide. All right. All right, and then we'll resume in just a second on the others. All right, so if you're looking at your screen now, you can see it's always a good idea to write your ions first before you write your formulas. All right, so iron 3 chloride, iron 3 plus, chloride -1. I can do that little swap and drop deal to make FeCl3. All right, again, you can use your +3 charges. The chloride ion has only 1 negative charge, so I need 2 more chloride ions to balance off that +3. And that's where the 3 in the formula comes from here. Or again, you can do the swap and drop method. All right, nickel sulfide. Both of these, +2 for nickel, -2 for the sulfide ion, 1 of each. Even though they're positive and -2, we only need 1 of each. All right, so that's where the swap and drop comes in. If you did your swap and drop, you had this, Ni2S2, but then you need to reduce, and we get this formula, NiS, as the reduced version, all right, which is the correct version. All right, zinc chloride. Zinc is a +2. Chloride's -1. ZnCl2. This time, no Roman numeral needed. It was one of those that we made a mention of back up here in the chart, that zinc only comes in one flavor, so no Roman numeral is needed for elements that don't have more than one oxidation state. All right, last but not least, iron 3 oxide, Fe3 plus, O2 negative, Fe2O3. All right, and that's how to write formulas for transition metals and how to name them. All right, don't give a Roman numeral where it's not needed. There's always a hint either in the name or the location of the element on the periodic table as a clue to what to do. Okay, so make sure you mark your own periodic table for a reference, and that way you'll be more successful. All right.